All right, good morning. Thanks for joining us for part one of the Building Enclosure Best Practices shown through three-dimensional mock-ups. My name is Jenna. I work with the Community Energy Association as a Built Environment Initiatives Coordinator. I'm just going to give a quick introduction to folks on the call to who we are here at CEA. And then I'll pass things over to James Bourget with RDH Building Science to walk you through some best practices with building enclosure. And then at the end of the webinar at 9:30, Juan Rincon will close things out with an introduction to Fortis BC's rebate programs. And sorry, that's 9:30 Pacific time for those folks joining us from the East Kootenays. All right, Florence, thank you, James. All right, so as CEAs, as part of our commitment to truth and reconciliation, we recognize the importance of amplifying Indigenous climate leadership. So I just wanted to start off today's session by highlighting the completion of a passive house sixplex by Yale Nation. So Yale First Nation is a small First Nation community. Their territory begins in the Fraser Valley and runs along the Fraser River to the beginning of Fraser Canyon. So they're around what is now known as Hope in BC, and they were looking for an innovative solution to provide adequate housing for members of their community that would go beyond meeting minimum building code requirements. They contracted Britco Construction to support with the design, manufacturing, and installation of a modular passive house complex that could withstand the wet climate conditions of the area, reduce energy costs for residents, and offer a more environmentally responsible housing alternative. So this multi-unit passive house project consists of 6 two-story attached townhomes, and the 12 modules were manufactured at Britco Construction's facility in Agassiz while site foundation work was being completed, which significantly reduced the overall project deadline. And then once finished, the modules were transported to the site in Ruby Creek in Hope and installed in 5 days. The construction team then proceeded with completing the final connections, exterior finishing, and passive house testing to achieve a successful completion of a modular passive house project for the Yale First Nation. All right. So the Community Energy Association, who are we? CEA is a registered charity and nonprofit. We're committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. So we're the only nonprofit in BC focused exclusively on supporting local government and Indigenous communities on climate and energy activities. But what does that have to do with building better? Well, CEA's work recognizes that the built environment is a main source of community-based greenhouse gas emissions, and that action in these sectors can not only result in significant greenhouse gas emission reduction, but can also lead to enhanced community resiliency and energy security while increasing the comfort, health, and safety of our homes. Forward slide there, please, James.
Yep.
Perfect. So at CEA, we coordinate and deliver various activities and projects supporting contractor capacity development across BC. And today's webinar was made possible through Building a Legacy North and the Kootenay Clean Energy Transition. So since 2021, the Building a Legacy North initiative, a collaboration of CEA and the Canadian Home Builders Association of Northern BC, supports high performance building through the implementation of the BC Energy Step Code and Zero Carbon Step Code in Northern BC. So Building a Legacy provides training and support for the building industry and local governments around high performance building in cold climates in both new construction and retrofit. The Kootenay Clean Energy Transition, or KCET, is a project that was developed to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KCET, CEA helps Kootenay and boundary communities prepare for a more energy efficient and healthy future through training and capacity building sessions like this one. So thanks to the generous support of the organizations you see listed at the bottom of this slide, we're able to offer this free webinar delivering insights and expertise from building envelope experts. And then for a full list of upcoming events and webinars on high performance building, you can visit our website just at the bottom of the slide there, communityenergy.ca/news-events. Then the next slide there, please, James. So a quick plug for those of you on the call who are doing retrofits. I just wanted to introduce the Home Performance Contractors Network. So if you're doing a heat pump install, window and door retrofits, or insulation upgrades, and your clients are wanting to access provincial and utility rebates, this is the network for you to consider to join. So becoming a member involves industry-specific training, and then upon completion of the training, you can receive training subsidies and costs back for the courses. So if you have any questions about how you can become a member or questions about this network at all, you can just reach out to the Home Performance Stakeholder Council directly using their info@ email address on the slide there. And we will be sharing these slides out as well, so you'll have their contact information. And then one last slide for me, James. Perfect, thank you. So CEA, we're committed to providing educational opportunities for everyone, regardless of their knowledge or experience level. And we prioritize providing a safe, welcoming environment where all attendees can engage and participate fully. So this slide just presents some guidelines we ask everyone to follow over the next 90 minutes. But above all, just please show respect to our speaker and fellow attendees, and feel free to ask any questions you may have. We're happy to address them. All right, James, I'm going to pass things over to you, but just a couple housekeeping items. If you have questions as we go through, feel free to raise your hand. I can call upon you to ask James directly. If you'd rather pop them in the chat and have me ask James directly myself, that is totally fine. We are recording this session. We're going to be sharing it out with all of you on the call, along with the presentation slides, and we'll be sharing it on our high performance building webpage as well. If you're a registered builder collecting CPD points, we'll be sending out a confirmation of attendance email later this week, so keep your eyes out for that. And then, as I mentioned at the start, after James's presentation at 9:30, stick around. Juan Rincon with Fortis BC will be giving a brief presentation outlining the rebate programs offered through Fortis. And yeah, so that's it for me. It's with great pleasure that I introduce James Bourget, Principal and Construction Specialist with RDH Building Science. So James has over 40 years of extensive industry experience, and we're lucky to have him here with us today, imparting some of that knowledge. So James, over to you.
Thanks, Jenna. Hello, everybody, and welcome to a webinar. We're going to look at high-performance building assemblies, what that actually means. For these mock-ups, we're going to be looking at split insulated wall assemblies, both 2x4 and 2x6, and there are some differences. We'll look at environmental separation and some of the strategies attached with that. This is the usual disclaimer that my partners make me say. This is for training purposes only. Don't run out and do everything yourself based on what you saw here. You need to understand that each decision is based on what climate zone, what type of building, what so many factors associated with it. The key here is to develop an understanding, okay? And then follow the applicable laws, codes, regulations, standards, policies, etc. Okay? Here's the agenda for today. We're going to look at the building enclosure environmental separation. Okay, so what does that mean? Environmental loads. We're going to look at some mock-ups. This is a two-part program. Part one, we're going to look at below-grade mock-up, cantilever balcony. We're going to look at the renewable detailing. So you got to think about, how do you change the membrane later when you put the controls on the outside? Why do you put the controls on the outside? How does that affect fire resiliency? What kind of thermal strategy is that? Does it actually make it more airtight? All of these things come into play. And one of the fundamentals that is important to think about, just because we spent the last 100 years building one way, does not mean it was the right way, because it does not apply properly to the laws of physics and environmental separation. It's just something we did, okay? I'll get into that a little. So what is a building enclosure? What do you think of when I say, what's a building enclosure to anybody in the audience? I mean, 192 people or something like this on this. What's a building enclosure? It's an environmental separator. What's it do? It separates the built environment from the natural environment. So you need something to separate that environment. So building science applies the laws of nature to manage heat, air, and moisture across the building enclosure like climate zone. That's all that is. There's a lot of different climate zones in the province of British Columbia. Right now, from climate zone 4 right up to 8, completely different environments, varying interior environments, and you need to design your building enclosure to meet the requirements by climate zone. We're pretty straightforward. The interesting is, fundamentally, you can virtually do the same thing across every climate zone and simply change, as I like to say, the thickness of the sweater. Just like when you go outside. On a nice day, you got a light shirt. On a heavy day, you got a heavy coat, based on the environmental separation required. I'll show how that applies to construction, actually. Separates the inside from the outside. That's a building enclosure. Okay? Keeps warm air in, keeps cold air out, okay? Or in the summer, keeps cool air in, keeps warm air out. It works both ways, okay? And this performance depends on the materials used, right? How it was designed, how it was constructed. That's it in a nutshell. Nothing too complicated. Here's the environmental loads. There's some critical barriers. There's 5 of them that we typically talk about. There's a 6th one being developed will come to life and is come to life. And the National Building Code is looking at that as a fire resilience, fire resistant barrier. Okay, so there's a sixth one coming, and it becomes a reality as we all become aware. But what does all this mean? You've got environmental loads, air, water, heat, vapor, and critical barriers. What the air barrier has a direct or indirect relationship with everything. So basically, it's really important. It's that simple. And so make it airtight. And remember that the air barrier is to reduce uncontrolled air leakage. Controlled air leakage is your ventilation. That's how a house breathes. Okay. Thermal affects 3 out of the 4. It's really important. So air tightness and thermal, envelope first, and adjust your mechanical. Vapor adjusts vapor. Water adjusts water. The one that has the largest impact is the air. Very important. A typical wall. Well, sort of typical. You can see that, put a little bit of that insulation on the outside. This would be a split insulated wall. In this case, the air barrier is placed on the outside. In conformance with the building code, you can have the air barrier on the inside, in the middle, on the outside. You can have 2 air barriers, no problem. But the one on the inside, on the warm side of the insulation, is your vapor control. And over time, we have inherently developed what I call PVD, poly by default. So the poly, typical, vapor barrier is taped and sealed. When you do not need to tape or seal a vapor control area, there is no word in the code that tells you to tape or seal your vapor control, only if you use it for air. So by default, the poly has become the air barrier, and we use an interior air barrier approach. Okay, and that's what I'm saying here. But it has to be continuous and sealed if you do that. So let's look at, this is the basics of a building. Let's look at the basics of nature. Here's nature, its finest. I live in the communities. I like this slide. It kind of works for me. Okay. And I'm thinking to myself, thermal performance and resilience by nature. Did you ever ask yourself, how does Mother Nature survive in every climate zone? Effectively, comfortably. Clearly, some have a bigger coat than other ones. And I thought to myself, how does nature stay warmer and how does your body stay warmer? Because you have to remember this. We're building an organic structure, basically wood. We need to provide environmental separation to protect that structure. And the biometrics between your home that you build or live in and your body are very parallel. I remember when I was a kid, I got that classic yellow rain jacket. That was my rain jacket, but made me more wet than when I was in the rain because it didn't breathe. Hence Gore-Tex, hence Tyvek. All these things become very parallel. So I was thinking to myself as I sit out here, I live in the forest in the middle of nowhere, a lot of time thinking, I guess. Says, how does your body stay warmer? So I said, well, I'm going to ask all the other animals. And they all responded in the same manner. Well, we all have a little layer of fat on the inside because that's what our skin sits on. Otherwise, the skin would sit on your nerves and muscles and you'd be all messed up, right? So everybody has a little layer on the inside. Some have more than others, but everybody has that. And then they have a fur coat on the outside. And the fur coat is contingent on the climate zone that they need to survive in. A hairless Mexican Chihuahua is not in the Arctic, okay? It's not going to survive well. It becomes a popsicle. And so then I asked my friends, I said, well, what do you do? And they said, well, we buy a good jacket. So everybody's putting controls on the outside, and all of you on the webinar today are sitting there, and you did the same thing this morning. Nobody put your jacket in a blender to eat it. Nobody stuffed it inside your body. You put it on the outside. Interesting parallel. So how should your home stay warmer? From the inside, the outside, or both? Well, we know how nature does it. So I was in my yard, and this here black bear was in my yard, and he's walking up, so we were going to have a talk about building science. He said, what are you up to? I said, well, I'm building a split insulated wall. He's looking at the wall there and goes, well, that's an interesting similarity because that's the same way I'm built. Let me see. I have a little bit on the inside. I got skin and a fur coat on the outside. It's the same. Well, that's pretty interesting. We're both split insulated. I said, yeah, it works for you. I think it'll work for my structure. The bottom line is this. We started with an empty wall. Somebody figured they put sawdust and debris and everything in there. An empty wall is R2. Put some stuff in there, sawdust, paper, drywall, scraps, whatever. It was a handy storage place. Look at all that empty wall space. And all of a sudden the wall got better to R4. And we realized, well, if we put stuff in the walls, it gets warmer. And that's true. But it still has a lot of heat loss and still had a lot of airflow, kind of like a hairdryer, right? That's how you dry your hair. Well, I used to, I don't have it anymore, but use a hairdryer, right? And so our walls would dry out by way of heat loss and airflow. And then as we started to go along, this was a good idea apparently. So we developed that insulation with Kraft backer, went from R4 to R8, each time cutting heat flow in half. But R8 is still not very good. And so we still didn't have any air barrier control. So we still had air and heat flow drying out the walls, surviving in every climate zone. No problem. Then in the late 80s, we had a little energy crisis. Well, we got to get R16. Well, we can't put that in a 2x4 wall. So now we're going to build a 2x6 wall. And now we get R16. Every time we did that, the exterior sheathing got colder and colder because the definition of insulation is resistance to heat flow. So the heat source is inside, that's where you are, right? And it's passing through the insulation because you can't stop heat flow, you can only slow it down. So you can provide resistance. And so as you're doing that, and the sheathing gets colder, you have to recognize that there is air leakage. And if you just think to yourself that, and I'll give you a quick example, at 20 degrees Celsius and 35% humidity, which is dry, dew point's 4, that's 40%, start bumping up to around 6. At 50%, the same 20 degrees is up around 9. So somewhere between 4 and 9 degrees. The comfort zone that we live in under ASHRAE standards, etc. Any air that leaks through that wall will touch that sheathing, will condense, because how often is that sheathing going to be below 4 or 9 degrees? I think the answer is often. So therefore, we have to hope that it will dry out. And the key is, and the reason that it has worked up until now is because we've managed to maintain this balance between rain and drying. Okay, and that was the first thing ever taught to me 20 years ago. Some of the founders of Building Science, remember this, James. Things may get wet, but if you have a balance between running and drying, that's okay. Well, I think to myself, why do I got to build something that's going to get wet? So I thought about that. And I looked at this here graphic of the climate zones again. I said, as we get colder, 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 the sheathing gets colder, colder, colder. That means the potential for that condensation, albeit it might be in ice, it's going to melt in the spring, but it's still wetness. So interior insulated assembly, I'm thinking, what can I do so the sheathing doesn't get wet? Here's an example, northern climate zone, north wall, 0.5 air changes, that wall, 5 years old. You got to wonder, the wall, no, I don't think we had imbalance between wetting and drying, and you can see that the vinyl siding sits right on the wall, the vinyl's vapor closed. Where's the drying potential? Because there's no rain screen needed because there's not enough moisture. So the code says, well, you don't need rain screen in that climate, but in order for the wall that's fat to dry out, because it will get wet, it needs rain screen to facilitate drying. So the mold index, MI for mold index and MI for moisture index, they kind of don't work together so well. That's because we're still trying to build the same thing we built from the beginning to make it work for tomorrow. Wow. More exterior insulation, warmer sheathing. So the more I put on the outside, it's just like you know, I put on a cardigan, then I put on a good old ski jacket, then I put on a pipe. Each time your body gets warmer. So where's your sheathing? If the sheathing's warm, it won't condense because it'll be above dew point. If I put all the insulation on the outside, sometimes with the perfect wall, the sheathing will be basically the same temperature as your coffee table. How long will that last? Now, I've seen furniture from the 14th century. How long will your home last? All of a sudden, we just have to maybe think a little differently. Here's an example on a 20 degrees Celsius and minus 10 temperature range. Okay? No exterior insulation. Your sheathing's going to be cold. No kidding. I put 1 inch on. All of a sudden, I'm just above zero. The sheathing getting warmer, but it's still not within that dew point zone between 4 and 9. So it's probably not quite good enough. What if I put 2 inches on? Well, I'm in the middle zone, so I might get some wetting, I might get some drying. Here's the deal. If you put some exterior insulation on the outside, okay, in this case, I'm showing vapor open insulation because our vapor drive is still to the outside, is all of a sudden, I have strapping to hold my cladding. So even the vapor drive and slight bit of wetting that might occur at 2 inches of insulation will pass right through vapor open insulation because it's an order of magnitude more vapor open like mineral oil than Tyvek is, just in case you're wondering. It goes into this vented space and dries out effectively. There's a whole bunch of other benefits, which I will talk about. I put 4 inches on the outside, which is what I like to do. 2 layers of 2 inch, and all of a sudden I'm sitting around 9 degrees. So this wall is never going to see moisture. Water penetration resistance is huge because all the insulation are hydrophobic, the joints are staggered, and all of a sudden my structure is sitting inside control layers. How long will the structure last? But I hear that, oh, this is too hard to build. Well, it's little rectangles of fuzzy stuff you stick on the outside. It's like we put plywood, that's hard rectangles of hard stuff we put on the outside. None of this is hard to do, it's something different, okay? And I talked about perfect wall. Put 6 inches on the outside. That sheathing is virtually room temperature. How long will that last? How long will a 2x4 last on your kitchen table? Like it's just forever. So all of a sudden you start to build generational type homes using the laws of physics to extreme durability. Never mind that if you use, for example, mineral wool, you have a 1 hour fire rated wall assembly with 1.5 inches on the outside. Okay. You use perforated metal insect screens, you have ember guards, you have climate adaptation built in. All of a sudden, everything is complementary on the building. How about air tightness? If we put an air barrier on the outside and I put insulation on that, and I press the insulation against that membrane, it's going to get more airtight or less airtight? Well, I think the answer is obvious and get more airtight. Well, so why am I not doing this? Well, I am. We're going to look at, do you guys see a blue streak just across the screen there?
We do, yeah.
What is that?
It could have been, I can get rid of it. It might have been drawn by accident.
Okay, I don't know.
Go
It just
ahead.
came across like blue line in there. I don't know what that was. I don't know. Disregard the blue streak. Okay, I don't know what that. It just showed up. Look, everything that's green here talks about air control layer. Okay, and so you go below grade. We're going to look at a below grade mock-up shortly, but concrete can be an air barrier. The waterproof membrane on the outside of the concrete can be an air barrier. You can have sealed insulation. Yes, you can seal the insulation, but I don't know how well it's going to survive the pour process. But this is all possible. Possible and practical don't always mean the same thing, okay? You can have sealed polyethylene, but no insulation, all right? You can have slab and poly. What happens most of the time is along this type thing here, sealed insulation, but we don't seal the insulation. We seal the poly on top of the insulation, okay? Is a typical approach for below grade. Well, that's fair enough. Now we're going to look at how do you connect this floor by whether it's providable radon mitigation as well as vapor and as well as air control. How do you connect that to the walls, okay, and the foundation walls? So we're going to look at below grade assembly detailing and some of the considerations. And I know there's lots of different ways to below grade. I'm going to share what I believe, and then I'm going to explain why. Okay. But still, no matter what, you need continuity of your controls, okay? Air, thermal, water need to be continuous from the bottom of the floor, connect to the foundation, up to the framing, over to the roof. All of this needs to be continuous. Thermal mass, what is that? Well, I look at it this way. See, if you're going to dig a hole, which you don't have to dig a hole to a house, by the way, but if you're going to dig a hole, okay, and we'll put concrete in there, that's thermal mass because it's like when you build a fireplace or campfire, barbecue, outside pizza, or whatever. What do you instinctively put around the heat source? Rocks, stone, brick, thermal mass. Why? Well, because it absorbs all that heat and holds it. And when it dies down, it gives it back. So imagine this. If I have concrete basement and I warm up that space, the concrete will absorb that heat. Why? Because I put the resistor to heat flow on the outside of the concrete. So the concrete holds this. I go to bed at night. I turn the heat down. What does the concrete do? It gives me back the moisture into the room to moderate that room. So all of a sudden, my basement smells as fresh as my living room. No more of that musty basement, that eau de basement by Chanel. It doesn't sell anywhere. It's not a very nice perfume. So why are we putting insulation on the inside of concrete, leaving it 8 inches exposed on the top side to be super nuclear cold? so that you can get condensation on the top of your wall in the basement and have a nice musty smell. That doesn't apply to the laws of physics. It applies to old behavior. It actually doesn't, in my opinion, meet building code because you do generate moisture. You didn't provide a means to dissipate to the exterior, which is outlined in part 9. It's like, that's interesting. So that's some of that moisture management below grade. I'm going to look at that on the outside because you got to think to yourself, moisture management, concrete foundations crack. Concrete cracks, this is an age of concrete. Oh, well, whoop-de-doo, no big deal. Because if I put my controls on the outside and I have either a couple layers of emulsion coating or I might have a waterproof membrane, one thing I don't put is that dimple board on the concrete directly with no membrane and this make-believe termination bar with gaping holes in the corners, okay? That's just, doesn't make any sense, okay? I'm not even gonna go there. Okay, and then transition detailing, concrete foundation to wood framing, from the slab to foundation wall. We're gonna look at that. So what I'm gonna do now is I have a physical mock-up here that I have. It takes you from below grade, takes you up the foundation, takes you through exterior insulated foundation up to a split insulated wall assembly above it, okay? And there's one penetration electrical just for fun, okay? You're gonna notice when I show you this insulation on the outside that half of that below grade is mineral wool and half of it is XPS. And you're going, why? And so if you look at that picture, you can see in the middle, why is half mineral wool and half XPS? Well, I'll share a little story, okay? And this has to do with fire resiliency. And so my friend lost his cabin. I went to look and I said, well, why is the outhouse floor so close to the top now? And he goes, it's not. The top's that much lower because all that biomass, it burned down for almost 2 feet after the forest fire passed through. So I put a fire resilient foundation starter, basically a 2-foot band around. Same principle. Can you use mineral wool below grade? Uh-huh. XPS? Uh-huh. And now I'll tell you what I did to keep it all functioning indefinitely and for extreme durability. So I'm going to switch over now. I'm going to stop sharing my screen. And I'm going to go to the left side.
James, we do have a question that popped up while you're switching over here.
Yeah.
Ken just asks, are there higher risks of leaks in exterior face, creating structural failures with higher levels of exterior insulation?
Yeah, so here's, and listen to my words, and I'll share a story, okay? Because this is what I do, is I build things, I'm in a studio and I test stuff, okay? And so if you provide an exterior air barrier, no matter what insulation you put on the outside, it's hydrophobic. Ideally, you put 2 layers of insulation of whatever thickness on the outside and the joints are staggered, okay? If you do that, it presses against the air barrier, it makes it more airtight. When you put exterior insulation by default, you have exterior strapping, which screws through the insulation to the structural backup, providing a compression seal, like a car door, casement window, it doesn't matter. It doesn't make a leak of any kind, it makes it more airtight. Then you have the cladding, so you have a capillary break between the face of the insulation, which is hydrophobic, and the cladding, which allows for any incidental that gets past your cladding, which, you know, an eyedropper here, an eyedropper there, because the cladding is your water shedding surface and it should be continuous, it's just going to run down the backside. So to answer your question shortly, there is no chance you're going to have leakage or issues with that. And to make a point, there's an ASTM standard E1105, which you can test windows in high rise at 720 pascals of pressure differential, which is huge, okay, with a rain rack. And I thought to myself, well, I'm going to make an impact. And I did the same thing, and I built with my students. We built 2 layers of insulation on the exterior wall of the window. We put them in the same test chambers, and we didn't test them to 720 pascals because that wouldn't be fair. I tested them to 9,000 pascals. So I simulated a 441 kilometer an hour wind in a rain rack test chamber. And in over 2 years and 50 tests later, I never saw 1 drop of water in the powder. You got to think to yourself, well, that's pretty powerful. So why are we building that way when we have all of this resiliency built into it? And I'll talk about it when I come back and show you some slides, okay? I'll talk about a little bit more about the first, second, potentially third plan protection. Hope that answers your question.
Thank you.
Okay, everybody sees that, right? The sheet is working properly?
Yeah, we see it.
Excellent, excellent. I build things, this camera stuff is, I'm getting the hang of it, but well, you know, what the heck. All right. This is a 2x6 split insulated wall assembly, okay? It has 6 inches of mineral wool on the outside, so 2 layers of 3-inch on the outside. So I have R16 here, I have 6 at R4, 24 here, I have an R40 plus filled in that. It's over an R40 top wall. This would survive in pretty much any climate zone, acting British Columbia. Let's start a little bit. You can see here, I have 2 layers of 3-inch XPS with a drain mat. The drain mat is on the outside here. There'll be 3 draining still down at this point. I have a membrane that comes off the waterproof membrane, or it could be emulsion coating, doesn't matter. But it closes off this drain mat core, so there's no dirt and debris and everything that gets trapped in here, which I see all the time. We're even at the dimple that gets put right on the concrete with that termination block and the gaping holes in the corners. How much dirt and everything goes behind it? And then you think to yourself, water can also get behind there, so if that concrete cracks, you're gonna have a leak in your basement. Hold that thought and look. If I have it outside here and I have waterproof membrane, everything is directed out if anything ever got past here. But hang on. Up here, because in part 9 says if there's any chance of water to get to the water resistant barrier, air barrier right here, it must have the means to dissipate to the exterior. Well, I tell you right now, no water will get to here. But the building code isn't caught up yet. It says you can exterior insulate, but the language isn't exactly conducive to doing that in the most common sense manner. So that's okay. It's transition, right? We'll all get that. And so I have the same few flashing membrane that comes down here. So any water that ever got out of this, comes out here. The same applies here. With my concrete. If I get any cracks in my concrete, there's no water going to show up in my concrete. So I'm also managing to maintain my thermal mass. So as I warm up my basement, this is going to hold all this heat because I got the resistance to heat flow on the outside. But this kind of all makes sense, right? So it's okay. I'll talk about RCF for those that are going, what about RCF? And so here you can see when you have insulation, you have a cavity, which is a rain screen cavity. You can see right into here, the 3/4 gap. You can see the perforated insect screen that's sitting right here, and electrical penetration. Electrical penetration is done with a rubber gasket, and I'll show you that on the slides. What I have now, right here, this here is a concrete board, which I have parched to look like concrete foundation. So when you look at this assembly, it looks just like a typical one with the insulation's on the inside. This is a durable board and boundary around here. It looks lovely. If it gets damaged, simple to fix, no issue. Very strong. Just thin set mesh, put onto cement board. You can wrap it all the way around. You can do it before, you can do it after. So here's a typical rain screen assembly. This is your water shedding surface. This is your thermal control. This is your air and water control. It splits off here and goes from water. The air barrier carries right down, and is attached to the concrete. But now it's going to transfer to the inside. And I'm going to show you that. So I'm going to switch the camera. But before I do that, does everybody follow what I did so far? Any question?
There was a question that came up, just whether there are any concerns with moisture wicking up through footings and where that moisture moves to. So when sealing the exterior side of the foundation wall to the transition of the floor wall, traditionally the 6 or 8 inch grade clearance band, does this moisture move just to the interior? So any concerns with moisture moving to the interior, wicking up through footings?
Moisture moving to the interior from which?
Oops, sorry. I just lost the question here.
Vapor drive from the inside space here, by default, usually follows heat flow. Okay, and it's this way. This is hydrophobic. Okay, and I'm going to show you what that means with a piece of insulation. Okay, and some water. So there's no wicking of water through these types of insulations, and I can probably do that for you right now. Let's see if that question came up.
Maybe I can explain it. I asked the question.
Yeah, go ahead.
I've always wondered about this in any type of assembly, that you have footings that could be, well, they are in a moist condition, depending on water table and so forth. And that concrete acts as a capillary. It acts as a water pump, wicking that water up. And it's either going to want to flow to the inside, to the warmer environment, or to the exterior. And when I see, well, I've always had an issue with that, even with poly on the inside is probably worse, but where does that moisture go, or how do you control that moisture from actually pumping up from the wetter condition of the base of the footings?
Yeah, so when you, depending on what type of foundation you're doing, but the inside on the basement floor, you have a granular fill. The reason you use that is the spaces behind that are so large the water can't climb. Okay, you have the poly, there's a full stop for gas and or vapor. So there's no issue with the floor whatsoever, okay? If you have a footing, all right, and you have the water that's gonna wick up from that, okay? You can provide a gasket when you pour the walls, okay? Basically, rising damp stop.
But that never happens because it's not code, right?
Well, I appreciate lots of things don't happen, my friend. I'm telling you, there's a whole bunch of stuff that doesn't happen.
Yeah.
And so what doesn't happen so much is most of the province is quite dry, okay? I mean, they have pressure treated wood foundations up north, okay? We have concrete, okay? So we don't have this issue per se to that level. Where you do have a water table of that nature, you should be providing a means for that to be drained out in a waterproof membrane, okay? And so depending on where you're building in Richmond or down on the coast or anything like this, well, it does get done. Is this something that you've seen a lot of? I understand what you're saying, it's called rising damp in the concrete.
No, I just seen 30 years of it, and
Yeah.
I know it's a problem. So
Yeah, I know, and I love the question, and for all of you out there listening, I love this stuff, okay? So you've got questions, and you just ask, okay? It's all good, because we're all there and grow together. If we don't ask questions like this gentleman just did, then we don't have discussion. And I think it's really, really important, okay?
Yeah.
About everything. So one of the things, there was some issues with moisture. I'm just gonna show something quickly here. For those that may not be familiar with it.
Yeah.
I'm gonna take a drink of water. I'm gonna do it here. First, you hear it. Now you know it's real water. So you can see the water on this. It's almost like ball bearings. It's like new car finish. It's highly hydrophobic. It's not coming to your envelope and it's not wicking inside. It's free draining when it gets wet. I'm gonna move to the back. Yeah.
We had another couple of questions come up about the
All right.
mock-up. What is the black membrane on the concrete foundation?
Okay, that there is a self-adhered SBS sheet, okay? Because you can put a waterproof membrane in it, and I think to myself, this is really simple to do. It's like peel and stick or below grade on concrete, okay? And I think to myself, if you dig a hole, why would you cut corners on sealing that concrete? Because it's not expensive. The material here costs us less than $1 square foot to buy. So I say to myself, why would I cut corners? Because if I ever had to fix it later, it would be highly painful. And so you can do 2 coats of emulsion coating if you don't have your water table. That's okay. And it'll work just the same. It's just black spray on pookie. This is a black peel and stick membrane, very much like roofing porton, but peel and stick. Okay, they make tops for this. Blindside waterproofing, dual salvage, where you peel and stick the field, but you can heat assist and torch slabs. Inexpensive, highly effective. It's got a sand finish, and I can glue my insulations to that sand finish because that's how we do roofing. I'm actually a roof consultant also. And when we do roofing membranes with insulation, we glue it all together with polyurethane spray foam adhesive, which I'll show you in the slides. Okay,
Great. And then what is the air barrier against the foundation?
air barrier at the foundation. I love it. Love it. Okay, here's the deal. Here's a question back to y'all. Can you blow through concrete? Nah, it's silly talk, right? The air barrier, which I'm going to show you now, is going to transfer from the polyethylene. It transfers through the concrete to the peel stick membrane in this imaginary line like this, because the concrete is airtight, it's solid, okay? And you're taking a straight line across like this to this waterproof membrane. Now, if this concrete cracks behind the waterproof membrane, this membrane itself is viscoelastic, okay? It's not going to crack. Concrete can crack behind it all day long, doesn't matter. It's still going to be continuous membrane on the outside. So that takes us, and I'm going to show you the other side in a moment here, but that takes us across. We come up on the waterproof membrane, then I have peel stick. This is foil colored, but you got blue skin, color what you will, okay? Resisto, I don't care, whatever. I happen to have Soposol and HD, which is a foil base. So I connect that from the membrane, foil base comes up to the wood. So now the wood's connected to the concrete by way of that membrane. The tieback comes down, water resistant barrier and air barrier, and it's lapped over that and taped to here. So now the tieback connects to the tape, connects to the foil base, connects to the membrane, passes through to the concrete, connects to the polyethylene transition on the inside, which I'm about to show you. Does that help?
I think so.
Okay. Well,
Thank
again,
you.
thumbs up, some I'll move on. Right? I don't want to leave anybody hanging. I've been on the other end of that where I had questions and didn't get an answer. Now what I'm going to do, go on. Switch cameras. Okay, so now I'm going to talk to you all here. Yeah, now I can see it. So what I have here is I'm going to take this apart and I'm going to start from the bottom up. Concrete, very heavy. I'll keep fun. We start with our free draining fill, wide spaces, no capillary wax, okay? Some like to put the poly down on the rock. I think that's the idea because you have some sharps and you can cut that and damage to be caused. I would much rather put it down, let the damage happen here, as you can see, from the loading at 150 pounds of cubic foot of concrete from that building. I now have my polyethylene. So the way that I do this is just how I do it. Means and method is a funny thing. Everybody seems to do it their own way. But what I find amazing is poly is the only material on site that nobody ever measures. Carry it on your shoulder, right? You throw it down, you give it a good hard kick, it rolls out, you cut it off. But that's all right. So I tell you what I did and what I do when I'm training builders on site and working with them. I show them, and then guys do whatever you like. But I'm going to show you a simple, easy way. So common practice that I work with is I'll power wash 12 inches of base of wall. This will get everything down here anyways. But I'll blow the foam all leaks and then leave off the concrete nice and clean. Now you have to ask yourself, do you know what height the concrete is going to be poured at? And the answer is yes. I know it's slope. I know where I'm pouring my concrete to it. Well, of course I do. Well, then could you snap a line where that goes? Yes, I can. So if I snap a line where that goes, would it also make sense that I can put this tape at that line? Yeah, that makes sense too. So here's what I do. You'll see that I have pieces of polyethylene because I'll take 16-inch plate poly and I'll pre-strip the basement, the rebase, the corners and everything. And I'll do a nice, tape it up, and I bring my polyethylene 1 inch from my pour line and I put my acoustic seal 1 inch below that. And I put the tape, which is a high performance tape designed for body concrete. And all I can tell you is you can bring your best fingernail to the party, but you're not getting that off. And so during the pour process, any dumps, pumps, slough down the walls, so it won't get in behind your air, they control it. It's well bonded, so it becomes a little bit tradespeople proof. Okay, so here's my plate polyacrylic on, and then I cut out a piece of poly to match the shape of my floor, and I take it to the plate poly. The important part that you have to recognize is the code's kind of silent on the requirement for taping the laps in the field. And part of that is because, well, concrete's really heavy, and it's going to seal it up. It's nice. But the problem lies that during the course of work, all kinds of debris and concrete, rubble, and gravel, and everything get in there, which can really muck you up a bit. So common practice would be to tape your field. But here's the deal that you got to consider. As I come along here, and I have a joint here. This is a stop where leakage right here, okay? And so I will use the high performance tape to tape this off, and I'll use the interior tuck tape to tape the rest off. But I will make this connection, like I talked about my concrete, come across and back up the outside. I test these, do this often for a long time. Highly effective, very simple. The last gentleman I worked with was a 65-year-old gentleman, or didn't want to retire, so I'm renting this in the basement. And he's now their basement expert. He just goes down there and off he goes, strips it all in, cuts it, slow, methodical, lovely. His building inspector came by, and I did his gaskets and that, which I'll show you in part 2 about. The building inspector came by, looked, and I said, "This is amazing." He said, "This is excellent, excellent." And so there was a win-win there. That gentleman who was in one of the tire, retired. Builder got very, very good airtight. Love it. And nobody gives something like that. Questions?
Oh, I was just going to say we have a couple questions, but keep going if you're.
Okay, well, I'm just about done, but one of the things, and I'll do my slides, is you can see right here. I use a tension tie, okay, to hold this down with anchor bolts. Yes, you can do this, okay? I didn't make this up. Simpson tension tie. I've done numerous projects. The problem is everybody wants to use those strap ties that come off the outside, spoil the concrete, and basically are not conducive for any kind of air barrier strategy whatsoever. They are, well, they're kind of silly. Then you can see here that I have the polyethylene on this side. There's no pookie. That's what I call acoustic seal. There's no tape. There's no nothing. There's no need because the air barrier is on the outside. On the outside. I'm not taping this for an air control. I'm doing this as vapor control. And here's a simple thing to remember for vapor control. If you cover 95% of a wall, it's 95% effective. Vapor control is one-dimensional. Air leakage is three-dimensional. And so it's really quite simple. Vapor control is not your major moisture transport mechanism. Your major moisture transport mechanism, air leakage, okay? Vapor is measured in nanograms. That's a billionth of a gram. Can't really know. The air takes all of this vapor. You can pass it through, and then it can go to the back side of that sheeting. Right back here. If it gets you that air barrier, that sheeting, without that insulation, cold. So this cadet condensation potential, now you have to hope it dries out. Okay, that's below grade. I'll take your questions.
Great. So just a question here about exterior insulation. Have there ever been any issues with siding sagging over time with exterior insulation?
With sagging?
Mm-hmm.
No. This has all been published. We actually at RDH, we did all of this and published all this information. But you can put it all the way up to heavy stone on this, and 1/64th deflection, well within any tolerances. You have to think about this, okay? Even a pull out on a fastener is, 550 pounds. And a lot of times what happens is when I'm doing this kind of exterior insulation, I use a 3/4 inch exterior sheeting. It's about $1,800 on a 2,400 square foot home. It's not crazy cost, but the difference is you can now put the straps anywhere you want. One of the common things that people talk about is, well, I put 6 inches on the outside. How do I get the strap into the stud? Well, you have to think about that. That can be a challenge because you got 1.5 inches. And if you take that fastener and you're a little bit out, you can miss that shut. That's not very good. You don't want to be doing that. So if I put 3/4 shield on, I can put the fast straps anywhere. So when I'm doing this and teaching this on sites or in classes of wherever BCIT or around the province, is I'll do the layout for the straps right on the insulation. Line X, 16 on center, whatever I'm doing, 12-inch spacing through the fasteners or 8-inch, depending on what it is. And the loading capacity is tremendous. You can look at the LEAP guys, Leaders in Energy Efficiency Partnership, published guides. You can read about that. And stucco, you think about stucco so heavy, well, it's about 12 to 14 pounds a square foot. Take a little bit of sugar. It's not heavy. It's spread out over the whole wall. What about hardy vinyl siding? It's only anything. So this has been happening and going on for a long time. Like this wasn't just invented, right? And so there's no issue with sag, with deflection, crepe. Stucco systems are designed with expansion control joints. All of this works extremely well. It's the right thing to do. It's putting the controls on the right side of the wall, one thing. And it's already had the test of time. Just took a little bit of it in. Well, on the industry here in British Columbia, Canada, North America. Doesn't mean that they're hard. It's been going on for a long time.
Great. We have a few more questions here. Sorry, we have about 35 minutes left. James,
Okay.
just a time check.
Any
So we
other
have
questions?
we have a few more questions in the chat, and I see, Dan, I see your hand up there too. I'm just gonna ask the questions that were in the chat first, and then I'll call upon you. So there's just a question here in terms of a process that one of the attendees uses, just looking for some input. So as the insulation is also a vapor barrier, we often install the poly below the insulation. This helps prevent tears or punctures in the radon and also allows radiant heat pipe to be stapled to the insulation. Do you have any concerns with this?
You have to mitigate your radon effectively. And every penetration it gets through could be sealed with gaskets. I don't, there's lots of what ifs, to be honest with you. And I don't have a concern. The radon mitigation, 10 mils and all that is lovely. We can seal any penetration. There are great ways to do that. A 60 mil on reinforced EPDM, extremely air, gas, and water tight. So there's lots of ways that we can get about all of this stuff. I'm not concerned about any of that.
Great. Someone else asks, we're finding more use of spray foam to cover the crawl spaces and joist ends. Is there an exterior certified spray foam?
Yeah, so spray foam is a thermal barrier. It's not an air barrier. Okay, that's snake oil. That's a last tail, as they say, mythical myth buster. Yeah, buildings are dynamic. Spray foam is not. I can't even begin to show how many thermal images I have of buildings that have been spray foam that have air leakage in all the corners. Okay, tight air fit. Spray foam is usually used, like I've done outside buildings, okay, with thermal clips and spray foam. Okay, but I did provide an air barrier on the sheathing. I didn't use it as air control. I used it as thermal. But even at that, it split, separated all kinds of issues because you're chemical manufacturing on site. Okay, and if it goes sideways, what do? I mean, I stuck my hand into spray insulated roofs and I reach in the middle, it's all gooey. What am I gonna do with that now? What are you gonna do? Nothing is visible. So spray foam is usually when I didn't have a plan and I got these rim joists and these hard to reach spots. And I go, well, spray foam comes out in round clouds. Framing is all square. So round clouds don't fit well in corners unless you pre-strike accurately in the right direction. That's not happening. So thermal for air spray foam, go ahead. Make sure you understand if it's open cell or closed cell, direction of your vapor control, or if you're doing a split insulated, the ratios and climate zone you're doing it in.
Great, thank you. We have a couple more questions, folks. After the questions that are in the chat here, we're going to continue on just so that we can keep on time a little bit. So Dan, go ahead. You have your hand up if you want to ask James your question.
Okay, you hear me okay?
We do.
Yeah.
I'm just gonna add a comment. It's not related to what I was gonna ask, but I'm just gonna say, Ken, that I've got a bias against spray foam use. I did a project earlier this year. The architect on that project has a good side gig going, just remediating spray foam projects. So I would be cautious about the use of spray foam in buildings.
Yeah.
And I'm going back, I date back to Eufy, and you probably know Eufy, James, so. The thing I was going to comment on is when I was inspecting, when we first started seeing rock wool coming in to the market on being spec'd on the outboard side of the structural wall, I had a couple builders that were installing it using the pressure treated plywood furring strips at the time. And that was a little problematic because they weren't wide enough, and the rock wool is compressible, and they were screwing it on, it was making the siding wavy. So if you use something like a I don't know what your preference is, but if you use something like a 1x4, that's wide enough that it doesn't compress the rock wool. And
I got a comment on that, if I can quickly, because you can't use a 1x4, it doesn't conform to Part 9 because you don't have 80% net free area, it doesn't work out correctly. The other thing is dimensional can split, but what everybody's not understanding is you can build with an 8-pound or 11-pound, rockboard 80 or comfort board 110. But what isn't happening, and I see this over and over and over, Dan, and you're right, 100% right. But you need to countersink with a number 12, pre-drilling countersink. And what happens is the fasteners have a bugle head on them, and people are driving the bugle head into the wood and expect the mineral to hold that back. No, the idea is you provide the bugle recess, and it literally just sees it's amazing what it can hold and how straight you can actually, like behind me, that's exterior insulated window with trim and everything. It's straight as can be. I can completely control my entire install. Okay, that's what's being missed, because if you're using foam, yeah, you can drive that screw right into the strap. Okay, you don't need 3.5 inches. You only need 3 inches, 3/4 plywood. Lovely, and Bourget treated is ideal if you want something to meet the timeline, because if you build with this kind of controls, this building will last hundreds and hundreds of years. There's no failure mechanism.
Exactly. What I'm mentioning, this was something I was seeing about 15 years ago. Do you mind if I just make a comment on the rising damp issue as well?
Sure.
Just as a general comment. As an inspector, I've always advised the builders that the grades work out to ensure that the base of their footing is above the winter water table. And there's justification for that, because the cost of concrete now, you've got to basically compact and fill that area anyway. And if you're saving concrete, it's kind of a wash. And then also, I never had a problem with somebody putting a skim of gravel down before they put their footings down. And that creates some drainage barrier under the footings, and then footing bags as well is another option.
That's right.
So there's lots of solutions to solve the rising damp issue in concrete.
Yeah, if it even is a problem. Yeah.
Exactly. Thank you.
Thanks, Dan.
Thanks so much, Dan. Just another question here. So 3/4 inch sheathing is also a vapor barrier. What is the ratio of exterior insulation to interior if using 3/4 inch sheathing, so that you don't end up with a dew point on the sheathing vapor barrier?
Sheathing is a smart vapor control element, and it's humidity driven. So it's only vapor closed below 60% humidity. When it goes to 60, 70, 80, it becomes vapor open. And if you look under ASHRAE guides, you'll find that plywood is Mother Nature's smart barrier that has a variable humidity or permeance based on humidity. Okay, so if you put 3/4 plywood on the outside and it gets damp on the backside, okay, well, it passes through that plywood sheathing. Okay, the whole idea is not to have the condensation on the backside. The whole idea, if you stuff a wall, you're getting wet plywood. End of story. Okay, that's it. But if you put your coat on the outside, and the better the coat based on where you're at, you won't have any condensation on the plywood. And if you put enough on the outside, the plywood then, to answer your question, okay, is the vapor control, because that plywood will now be in an environment that doesn't reach that humidity, because ASHRAE comfort level at 55 is beyond the trigger point for the permeance change of the plywood. So all of this stuff really works well if you put the insulation on the outside, most if not all. Yes, you can skip the poly on the inside. Yahoo! I have builders that just go, no poly? Yeah! Yeah! Okay, that's the facts, okay?
Great. Okay, go ahead, James. Continue your presentation, folks. We have
Okay.
about half an hour left, so I'll keep track of your
Yeah.
questions here.
All right, well, I'll blast through balconies, which will be totally weird again, but that's okay.
All right, and you just have to bring your share screen up again.
Yeah, I'm doing it right now.
Perfect.
Share. That. Sometimes this computer's slower than I am. I don't know. There we go. So I have a cantilever balcony installation. This one's got a lot of stuff to talk about. I don't have a lot of time, but let's see what we can do here. So I'm going to wheel this thing over, but right now you can see that I have an exterior air barrier installed here. I'm using the blocking and the joists that cantilever through. I'm sealing around each of the joists. There's a simple way to do that. I have an insulation starter curb with a plywood facer. And you can see in the finished picture that the PVC membrane actually goes up plywood onto plywood. Everybody knows how to do that. I have my thermal control behind it. I have my air and water behind it. I have my cladding on it. And the point is, how can I change this membrane in the future if I build high performance putting controls on the outside? Well, quite simple. I have a removable baseboard. I take it off, I change the membrane, I put it back on. It's like incredibly simple. I do this all the time, working at RDH. I do large, townhouse complexes, the whole city block. We change everything over like this. Next time they do a roof renewal or balcony renewal, any kind of renewal, you pop the boards off, change it, and you never touch the controls. One thing you have to understand is as we start to be more stringent, we want to keep the energy inside. We want to keep the air tightness, okay? What's going to happen in the future if you have all that on the inside with poly? What happens? You ever do a renovation in a kitchen for a life of a home? Yes. Bathroom? Yes. You're going to mess up the poly and air tightness? Yes. Put it on the outside. So now if you put it on the outside, you're going to need to change your shingles. You need to change your PVC membrane. You need to change your BIC membrane. You need all of these 20-year cycle assets need to get changed. How can you change it? I can change this entire membrane, and I'll show you next week shingles and a whole bunch of other things. And I never have to take the cladding on, just the trim board. And so that's what we're going to do. I'm going to wheel that over now, and I'm going to switch you over to here. I have that balcony that I was talking about. It's exactly the same as the wall assembly, but here's the deal that's a little bit different. This is a 2x4 wall. In this case, I have the same 6 inches on the outside. And it just goes to show that if I build a 2x6 wall, I put a little bit back on the inside. The backside of my sheathing is going to be about 3 degrees warmer than if I built the same wall with 2x6. Why? You have more resistance to heat flow inside the sun space. Therefore, the sheathing will automatically be cooler. Therefore, my condensation potential will again be increased. So we used to build a 2x4. At least I did when I had hair, a young fella way back in the 70s, whatever, 80s. We built 2x4. That's what we built. And so now we build 2x6 out of habit for our 16, but it's not the right habit. When you can build 2x4, I would strongly suggest you do so and insulate on the outside. But I'll take you through the same talking points, quick and simple. I've carried the air barrier up. It carries all the way along. It carries straight through. Basically, it just passes right through the joist, but I sealed around each of the joists. And you can see that I can use the blocking as part of my air barrier. Can you blow through air through a piece of blocking? No. Can I tape around a joist? Well, I used to have my kids do that. It's like a grade 4 art project. It's pretty simple. Can I do this taping before I put the plywood on? Yes, I can. So it's quite simple to make that. It's called a receiver. So I have this tape is 4 inches wide, comes up somewhere around this point up here, this here wiggle out tape that I used, okay? And then I lap the tie deck over and I taped that tape. You can see that it goes all the way around and each of the joists is done that way. So as I come back to the front side here, there's a whole bunch of best practice things you got to do, and I'll talk about that, but you can see the edge has been routed to take the PVC coated metal with the PVC. Therefore, I get free drainage over the edge. The only projects I see where there's a puddle of water all along this edge, that's the complaint. You do all this nice work, and the client says, well, I got ponding water on my deck edge. So you need to route out the plywood here. In this case, it was 5/8 G1 extra and PVC. But the key here was I took my 3-inch insulation. Then I took a 2.5-inch insulation and a 1/2-inch plywood to equal 3 inches. So now it was exactly the same as the wall insulation, which is 3 and 3 on 3 and 3. Okay, but now I get the plywood on the outside and I fasten it with long screws right through to the wall. This now becomes my receiver for my membrane. So if I had to put insulation on the outside and I brought my membrane all the way back to the wall, this is my air barrier. This would create massive amounts of grief at the time of renewals. Can you do this? Yes, you can, but I'll put the same plywood on top of the tie deck and run the membrane on the plywood, not the tie deck, okay? And then I'll use the same through flashing tape to come over the wood, whether or not I have insulation. That allows me to change this later. An interesting part, if you look right here, this is not adhered, okay? This tape is loose. This is a water resistant barrier. It only needs to be shingle. This is my air barrier. It needs to be taped and sealed. So I can take this trim board off. I can take these straps off and I can change this membrane. Can you take membrane off that's adhered to the plywood? Absolutely. It's called ribbon stripping. If you cut any membrane in 1-inch strips, you can peel it off. I don't care what you've done to it. Okay? So I can peel it off and take it out. Alternatively, I can run my new membrane right up over top and lap my tape right over top of that one, because that membrane behind this clad is going to be in perfect condition anyway. So I have all kinds of options that make my life simple when I get time to redo my renewal parts. On the back side, again, I have poly, no pookie, no tape, no nothing, okay? My drywall finish, okay? Here, I ran XPS blocking, no spray foam. It's pretty easy to cut rectangle and pop them in there. What function is that doing? That's providing my thermal and my vapor, because it's closed. It's insulated. So I have thermal and vapor here in the form of batt poly, and I have thermal and vapor here in the form of XPS. That takes that through this build. So I can change this membrane anytime in the future. Pretty flat, simple. All I'd have to do is pop off a board. Take my little mini straps and bug screen off. Change my membrane, put the board back. And there's the dog leg piece right here, which I take off and do the same thing. Put the board back. Pretty simple. I didn't touch anything. So the integrity of my entire structure, 20 years from now, will be maintained. Because by code, you can only make it equal or better, can't make it worse. And if you muck them with the controls, 20 years from now, by somebody who might not know, that should make it worse. Then you can have other issues that can come up. So I'll take you through some PowerPoint on that. Any questions?
Yeah, there's a, could you explain your use of tuck tape there? It's just as your choice of tape.
Yes. So right here, okay, this here is shingled over, okay? Of this here, tuck tape, all the way down. Everywhere, everything's shingled. This is not really that important from shingling because this is behind this. See, I have this basically a through flashing tape, okay, that I bond to the mineral wool. You prime it with aerosolized primer and you can bond to mineral wool. Otherwise, it's like putting Scotch tape on a cat and then you're not going to stick very good. But I bring this, and this here blue membrane comes up the wall and then I lap this over. This is what the inspectors will look for. They'll refer to notes in part A that says you need 50 millimeters lap onto your flashing. I have the membrane coming up 50 millimeters and I've lapped over it. And so I have a means to dissipate to the exterior. So anything that happens above this membrane comes out here. It's my new base of wall. This is about maintaining air tightness and it's shingled by sequence of construction.
Great, thank you. And then this was just a question about the last mock-up that I thought would be in your presentation, but we moved forward a bit. So I'm just want to make sure it's not missed. What are you using for furring strips then on your rain screen?
Okay, what I use for my raised screen exactly is this. I found it cheaper to buy 3/4 inch Bourget treated plywood. Yes, you can get Bourget treated. No, you can't just go there today and buy it. You plan your project, of course you can get it. You can use MCA also. These are all quite conducive to the fastener and corrosion resistance of your fasteners, but I'll use 3 inches wide, 3/4 thick. My number 12 pre-drill and countersink, and everything sits absolutely flat and flush, as you can see on the mock-up behind me and when I'm sitting on the straight view with the window mock-up. So by doing that, I have about 81.25% net free area, which meets my 80% net free area, and also will not cause any linear cracking, because you have to understand, okay, if you are doing it and you're going for a stud, you're going to put fasteners in a very linear line, in line with the grain of lumber that might be not perfectly wet, okay, and perfectly dry, and over time can potentially split. Plywood will never split. And the 3 inch wide footprints gives me that net free area, where the 3/4 or 3.5 or 1/4 does not. So if you're going to do 1x4, it should be 2 foot on center. Or if you're going to do 16 on center, do 3 inch. And plywood is, Bourget treated plywood is perfect because it will actually pacify the fasteners and provide excellent corrosion resistance. Remember, just remember this. If you build using the laws of physics and simple common sense and processes, how long do you think this will last? There's no static mechanism for this wall. It'll last as long as your coffee table. In 600 years, people will come look at your house and your walls because they'll be fine. Just like the furniture in a museum is fine because it's kept inside an environmentally separated environment. This is not environmentally separated environment.
Perfect. Thanks, James. And we have about 15 minutes left there as you switch over to the PowerPoint. Thank you.
I'm going to take you through this quickly, but you can see here the insulation starter curve. You can provide this the same time as you do the tie-in for the air barrier tie, which I'll show you in the PowerPoint. But the plane of air tightness is right here, okay? And it's protected forever. Here's it taken to you just quick and simple, okay? Sometimes you'll have 2 plies or 3 plies coming through. You get massive leakage between those plies. You need to seal between those plies right there, okay? In this case here, I used a 2-sided butyl tape. And so the framers know how far it's projecting. You can run sealant, PL, I don't care what you put in there. Seal up between the plies, mount it, you're good to go. Ensure that there's some bleed out that you can tie your tape into. Great, super. Now, sometimes framing isn't nice. There's gaps, and this is normal. So I built this here with all kinds of gaps and problems. Well, how do I get airtight around a joist when it's got gaposis? Well, if it's not planar, I can install sealant. I use a 758, okay? And I fill that. I cut some gussets 2 inches by 3 inches, typical size. I can make a whole bucket of them. And I can give this to anybody to do it. It takes only about a few minutes to go and take care of a balcony. And so the same on the top side. I'll put some sealant. I'll put the gussets on. I'll set the gussets right into the wet sealant. Okay, I don't care. Okay, that's fine. It's going to tape to the plywood all around the sealant. But now I got a planar surface to work to. So all the gussets are on, all 4 corners. Bing, bang, boom, bing, bang, boom. And now I run the air sealing tape. And so after the gussets are installed, I put the tape and I use the blocking. So you can see now that I've made a receiver around the double and the 2 singles that can be expanded indefinitely in whatever big the balcony is, okay? And so, okay, I now have the receiver. And now I install my starter membrane. Starter membrane is your water-resistant barrier, your Tyvek, your sheeting membrane, synthetic house wrap, call it what you will, okay? But you're going to put 1 piece from the bottom because you build it from the bottom up, so it's shingled. So I'll put 1 piece on, and I lap over a 2nd piece, and then I tape it. It's like, so far I haven't done anything crazy, complicated. I just went around the joist, quite simple, and taped it. You can see now that I have my plate of air tightness. I can work with that. So now I'm going to put the insulation starter on. The starter, we'll do this. I've shown you one, the right-hand side, but the left-hand side will be exactly the same as a dog leg, and it's 2 layers of insulation. That's what I've done here. And I reduce the thickness of the insulation on the 2nd layer by a 1/2 inch, so I can put a 1/2 inch spacer of plywood on, so I maintain the same thickness. The same thing I did on other things that I talked about in the mock-up, okay? You look at, okay, that's simple. Offset insulation layers. I have a little rule of thumb. You'll see in guides, oh, you need 8 inches, 16 inches offsets and all this. I know you don't. you need to offset, a rule of thumb that I use is equal to the thickness of the insulation. Well, we got a 2-inch insulation, up 2-inch offset, 3-inch insulation, 3-inch offset. And I keep that rule of thumb. And it's not the end of the world, okay? All you want is some kind of offset, all right? Extending insulation beyond and around and up in between the cantilevers, okay? So you can see it going up on the underside. And so I'm fully insulated here. And you can see that just like a frame wall, that you have a joist providing a thermal bridge every 16-inch on center, whatever center you happen to build on. Well, it's not the end of the world, okay? We have insulation inside, outside, and the wood itself is roughly R1 per inch, so it's a lot better than steel. Now, if you wanted to not build a cantilever balcony, that's a really good idea too. Okay, you'll see a lot of times now on projects, they'll run PSLs out, 2 of them, and then run the joist this way, parallel with the wall. So now you've reduced the amount of penetration thermal bridges significantly. So many ways to look at this, okay, as we move towards higher performance assemblies. Again, looking at this here, trim boards are installed. I got some tapers onto the joist to provide some slope, but here's the deal. My plywood sheathing for the deck doesn't go all the way back to the wall, it doesn't have to. It goes 4 inches from the wall. So I'm able to carry my insulation straight up behind in a very continuous manner. Okay, I don't have a big ledger mounted on the wall or anything like that. It's continuous. 5/8 GVS member to route the outside. Okay, take a router, route it out to the thickness of your flashing so that you get positive slope over the edge. Start to look at this. I put my deck membrane on. Okay, a little bit of primer. I put the PVC on. You can see here that you might wonder, why have I installed a sheathing membrane on my last dog leg? Well, the reason is simple. I consider the mineral wool as a third plane of protection. I know that water will run down that mineral wool. I know that if I have staggered joints, it will just carry us down, and it's not, it's hydrophobic, so it doesn't whip the water into the joints either. It just runs straight down the wall. So put that down there just to kind of make a point, okay? PVC membrane and crickets, so water doesn't pour over the edge. You build a little cricket, and there's also what's called a hem cricket right here in the corner. So any water that does come down will carry on through. Here's that through flashing membrane, whoopsie, through flashing membrane right here. So I prime the top of the mineral wool and I lap it over the PVC. I can continue my insulation. That's simple. I can lap the sheathing membrane over right there, just like I showed you. That'll keep the inspector happy. Okay, my water resistant barrier is continuous and conforms to part 9. Okay, not that any water will ever get there. That's a debate for another day, but no problem. Easy enough to plan. Continue the mineral wool around, stagger the joints in each direction. You start to look at this and go, there's nothing that's been tremendously hard. Here's the deal. The insulation starters for every balcony is the same size. I usually cut a 12-inch, okay, and a 10-degree slope. So I just run it on my table saw. I come to the site. I have them already pre-cut. Everything's pre-cut. And so I just cut them to length and put them on the wall. It's like really, really quite simple. And so you start to look at the interface detailing, install the strapping, okay? And so it's interesting. I got to split the strapping up. Right there, the green, that's for my removable detail, because I'm going to take that off when I change my membrane. And around it is blue that I'm going to leave on with my cladding forever and ever, amen. Until such a time that I might do cladding change, and even then I'm going to leave it on. The strapping just stays. Done. Perforated insect screen, right there. That also provides an ember guard for fire resistance. So embers that blow into this corner as a perforated metal block won't allow that to happen, okay? And then you look at the other side, install blocking between the joists, because you do not want to vent your wall assembly into your balcony assembly. So you put blocking, whatever, I don't care. I had a piece of 2x6, so stuck it in there. And then I have the insect screen, okay, along the top of the wall. So that's how the wall is going to vent out forward. So when you look at that when it's done, I have this cladding that goes on, and I leave a gap about 3/8. Can't see it because the angle of my camera, but there's a gap that allows that wall to vent out, and the blocking stops any vented air, which can be hot and humid, by the way, just so you know. Soil air and ground moisture can create a nasty environment and go straight up into that space. Well, that deck might be cold and it condenses to the underside of your sheathing. Now it comes out, mixes and tempers, and that's what you want to do. Don't vent into your space. Continue the wall cladding and insulation. And you now have a completed PVC deck or balcony membrane that all I need to do is take off these two boards, well, and then run down the other side, wherever it might be, whatever your orientation is. Take off the little mini straps, which are right here. Take off the insect screen, change the membrane, put them back, put the board back. All the cladding on the blue strapped areas is retained. You never take anything off, so all of a sudden it becomes incredibly simple. What I'm seeing over and over and over and over and over is the use of minerals starting to happen. And they'll run it right down to the shingle lines on the roof. How are you going to change the shingle layer? Run it right down to the deck line. How are you going to change the deck layer? Put your torch on, you melt the tie deck. Why are you doing that? This is all stuff that we can talk about. Again, we'll get into part 2. But all of this comes to an end if we start to move the controls and start to change the way we actually apply these controls to our structures. They become complementary. They now adjust for the human factor. Okay, buildings get more airtight, more resistance to water, more resistance to fire, less sound, better for sound. Everything becomes better. Instead of putting everything inside the wall, having to make this crazy inside air barrier, make sure the outside is perfect, and all we end up is a wetting wall that might or might not work, and we kind of hope it works. We can do better. Use the laws of physics, death, taxes, and physics. That's it. That's all we got. You can
Great.
move.
Sorry.
Now, I can do some testing, but I don't have time today. But I'll do that next week, okay? But just so you
Perfect.
know, I have a test chamber. And, well, I tested the balcony earlier. It's not very exciting because nothing leaks, okay? Just, you know, I got windows here, all these different things. I can test penetrations, line set, heat pumps, and all the rest. I'll try to plan next week to, by a little time, we'll do a little bit of test chamber stuff, okay? For those that, okay, well, is it really airtight? I think as you watch the slides, you can see that. Here's the deal. I'll give it to you. I'll give it to you straight. If you recognize a point of air leakage, if you recognize a transition, okay, an interface that needs to be addressed for air leakage, if you only make a reasonable effort to address that air leakage, when you test that building, it will be less than 1 every time. The problem is things like a garage on the front of a home. Is that part of air barrier strategy? No. Well, it connects to the sidewall. How do you transfer the sidewall? Come to the back of the garage, back up the side. These things are overlooked. Transitions, concrete wells, you know, slope side entries out the backside. All this stuff is not looked at because we just keep doing the same. Who's in charge of air tightness? I don't know. It's not that difficult at all if you just stop for a moment. I do a lot of napkin sketches with builders, or, you know, go for lunch, have a burger, and draw a sketch and say, well, how are you going to transfer that floor projection out? Well, we can do this, can do that. That's it. Yeah. Well, it's not hard. I can always, none of this is difficult. It's only different. And it's only different because it's proper. And what we have built up to date thus far, stuffing insulation in walls with poly and air seal on the inside and condensing top sheathing potentials on the outside, is not defensible. As we move forward to preserve our energy, okay, and maintain our air tightness, we're into air quality for human comfort, and all the, you know, all this is lovely. We all chit chat, I chit chat over. You know what the end thing that always is mentioned to me every time? Nobody really cares. The only thing they really care about is comfort. There's lots of squawk along the path of comfort. But at the end of it, if it's comfortable, everything's forgotten. It's lovely. So that's it. How am I doing on time?
You're just on time. We just have a couple minutes left here, so we'll wrap things up and pass things over to Juan. And James, I've kept note of the questions that we didn't get a chance to answer today, and I'll share them with you before part 2 next time, so we can see that if we can integrate them there.
100%. We'll address them right out of the gate.
Perfect. All right, and thanks folks who are taking the time to complete the feedback poll. We'll have a look too before session 2. So if there's any way that we could have done this session better, let us know for next time, and we do consider that when we plan out future high performance building sessions as well. And yeah, James, just a big thank you for sharing. I know that was a lot of information and in a short period of time, and appreciate it, and appreciate the use of the mock-ups, folks. I hope you found that helpful. And go ahead, keep popping your questions in the chat too if you want us to bring them to James next time.
Just please recognize that these aren't made up. This is actually taking place on sites all over the place, okay? Many builders are, putting aside past behaviors and past ideologies and accepting and embracing the future, and tremendous success. So many builders I've worked with are calling me, I got 0.2, I got 0.3, oh, I got 0.6, it didn't go that well. Air tightness has been amazing. And again, a few of them are still rejoicing over no poly, just saying.
Great. Okay, James, we'll see you next time on December 3rd, folks. I did put the registration links in the chat, but I'll have it in the follow-up email as well. All right, so Juan with Fortis BC is joining us just to give us a little bonus presentation on Fortis BC rebates available.
Wonderful. So thank you for having me here today. James is a bit of a tough act to follow, so I do my best to keep it concise and entertaining for folks. What I wanted to share here today is a little bit of the set of rebates that we have for making homes more efficient. We believe that the best approach is the building science approach, kind of what James has brought up here in terms of going for the building envelope first, if possible, particularly on new homes, building right from the outside inside, going into the inside. And then for the folks that are looking into renovations, we also have options for rebates. We're going to be speaking about those shortly here. But again, if you can look at building envelope first, airtightness first, would be the ideal approach. I'm going to be speaking a bit about our dual fuel heating system, which is a sort of relatively new offer that we're providing for our customers that has had quite a bit of an uptake. And then for the folks located in the Kootenays and South Okanagan, the electric rebates that you are eligible for under our programs. So I am the program manager for energy efficiency, education, and community outreach. So we're supporting this session here today, to work towards the province's goal of reducing greenhouse emissions by 40% from the 2007 level by 2030. And then we have our internal goal to contribute to achieving to the province a goal of 80% of greenhouse gas emissions reductions by 2050. So let me see if I can move to the next screen here. So, we like to focus on space heating because that is the bulk of the energy that your houses uses. Is something that not everybody is aware of, but this is kind of where the biggest bang for the buck is in terms of reducing energy and greenhouse emissions in your homes, in terms of heating compared to water heating or whatever you can use on lighting or other appliances. So going to the rebates right now for new homes, for the folks that are in new construction, we have a dual fuel option, which is when you combine space and water heating system in a home or a furnace integrated with a heat pump and electric water heating. We have rebates for those, as well as for folks in, like I mentioned, in the Kootenays, if you have an electric furnace or a baseboards or heat pump combined, we have rebates available for those. We also support the integrated design process, which is when at the beginning of the construction, you have all the trades sort of coordinated to make the best plan for the building, up to $1,000 for integrated design process, and $3,000 if you have a building envelope design, and $3,000 if you have the mechanical design pre-planned as well. As far as rebates for new homes, we also have a different approach for folks that are shooting to build to step 4, which is one step beyond what is the minimum step required by the province. We have a $50,000 rebate for those, and a $20,000 rebate if you're going all the way up to step 5, which is almost passive house, for those that are into that area. We have rebates for dryers, washers, fridges as well in the electric side, and drain heat water recovery systems if you are able to put one of those, and connected thermostats in your new home. Those are the smart thermostats that you can program through your phone or an app.
Hi, Juan, we have a question. Dan has his hand up. Can we call upon Dan to ask his question?
By all means, yes.
Yeah,
Go ahead.
thanks, Juan. I just wanted to comment that I've worked as a building and plumbing official for 20 years, but the last couple of years I've been working as a senior project manager for the city of Vernon. We're currently working with Fortis. Our consultant suggested to get engaged with the program. And so I'm doing HVAC upgrades on a number of our core buildings right now, 2 fire halls, RCMP, City Hall, and our community services building. So on the commercial side, we're actually doing the program with Fortis. We did energy studies. On that energy study, 75% of the study is covered with Fortis, and then if we implement the balance, the 25% will also be recovered. Just wanted to throw that in as well. It's a good program.
Thank you for the prompt there, Dan. Yeah, we do have commercial rebates as well for those folks that are on the. So technically, a city is considered a commercial customer. We have a whole set of those, and I guess that's a good reminder for me to let people know that if you're looking for any type of rebates, the best thing you can do. I'm sharing some information here, but we have over 80 programs. So I have a bit of a hard time fitting all of those programs within a 10-minute presentation here. So if you Google Fortis BC rebates, that's where you can find a comprehensive list of all of our programs. Like I said, we have over 80 programs. So I'm sure you can find something there for you if you're looking at becoming more efficient. And I'll also provide my contact information. You can reach out to me if you have any particular questions. Going into the home renovation rebate program as well. So if you're looking at doing some work in your home to make it more efficient, we have rebates for space heating, water heating, building envelope, as we mentioned before. And if you're combining a few of those at the same time, we have a bonus offer for that as well. So going into details, you have to be one of our customers basically is the requirement for our rebates. If you are not one of our customers and joining us from maybe the BC Hydro's territory, they also have pretty similar programs that we have for a lot of things. So you can take a look at those. This is mostly geared to folks that are living in the residence for most of the year. So if you have like a home vacation or something like that, it wouldn't really apply for that. So that's something to keep in mind. And additions to homes are not eligible even if they have like a separate account. Most of the rebates are geared towards single family homes, but they also, if you have a secondary suite, that is separately metered, that one qualifies. If it's under the same meter, it doesn't qualify. If you live in a townhome or a duplex or something of that line, we have rebates for those as well. And mobile homes, maybe some of the folks are in those as well. They are also eligible as long as they have a permanent foundation. In terms of the dual fuel heating system, and what I mean by that is when you combine a heat pump, that being cold water heat pump or just a regular heat pump, with a furnace under the AC system. And the reason we promote that is because we feel like for our climate here is one of the best options you can have for heating and cooling. We are giving a $10,000 rebate. So it has, like I mentioned before, been a quite popular renovation rebate program. If you are under the income qualified threshold, is $15,000 for eligibility on those. And I encourage you to look at our website. For indigenous communities is also $50,000. And under the Clean BC program, if you live in the north, we have a top up. There is a top up available for $3,000. There is also incentives for contractors. If you do a commissioning sheet and send that to us prior to installation, and like I mentioned before, if there is a certified connected thermostat, so we have a list of the eligible units for those. In combination with the heating system change, we have $150 additional for that. These are a couple of examples of the thermostats that I was mentioning, and the requirement is that they must be installed when you upgrade your system. Going into the building envelope stuff, we have rebates for insulation upgrades, and the thing to mention here, probably the biggest thing to take away, is that it needs to be performed by a home performance contractor network member for you to be eligible for that, and that is so that we make sure that they're installed with the right standards. Some of the areas that you can install insulation here, as a way of sharing a visual, is the attic. Is probably the biggest area you can tackle the easiest, the basement or crawl space as well. And if you have the opportunity to do the exterior, as James was talking about, that's probably a good way to approach it. It's a little bit of a busy slide here, but it's just these slides will be shared after this, and it's if you wanted to make a calculation of how much rebate you would get for the space area that you're trying to insulate, you can take this chart away and make some math on it. Maximum rebates are up to $1,200. These are some of the examples of the insulation. James was talking about the boards, for instance, earlier today. There is also spray foam, loose fill, and bath, depending on where you're installing those. There is advantages and disadvantages. One of the things that we really didn't talk a lot about today, that is sort of like an emerging discussion on this, is the embodied carbon of all of this. And on that regard, probably the loose fills, the cellulose loose fill is probably the winner there, at least up to this point. There is different products from different manufacturers, even under the same sort of realm or path of work. So I encourage you to take a look at those numbers and maybe look up embodied carbon. We don't have time to talk a lot about that here today, but I think, Jenna, you've made some presentations on those on the CEA website that you can share with folks, right?
Yeah, we might have some resources I can share out for sure.
Awesome. And then we also have windows and doors rebates, which obviously are part of the building envelope part. Same thing, they must be installed by licensed contractors. Self-installations are not eligible and probably not recommended. Skylights are the only thing that we don't rebate for, but for windows and doors, they must have one of the seals that are a certified product. And the label, you must submit a picture of the label along with the invoices when you're applying for this rebate. We have rebates up to $100 per window or door. And if you combine a few of these, up to $2,000. And heat pumps, right? So we talked about the folks that are in our shared service territory, and eligibility. The main part of the eligibility for you to take away here is that it needs to be performed by a contractor. And there are two types: the ductless mini split, which is a very popular option, particularly in retrofits for new homes. Probably a central ducted system is the most popular one. In terms of our dual fuel offer that I mentioned before, these are sort of the same types of heat pumps that you could install. And yeah, so up to $2,000 depending on the size and the heads of the system. Same as this, we have a heat pump water heater rebate for up to $1,000. These are a lot less common in the market. So please ensure that it's a qualified model before you move forward with this to get your rebate. And then, like I mentioned before, if you install 2 of these things in a retrofit renovation, you get a bonus rebate of $300. And if it's more than that, it could be up to $2,000. You can also get a rebate for upgrading your system in terms of providing a service to it for $50 for your heat pump. And we have rebates for Energy Star appliances up to $250. So I'm sharing here the website that you can reach out to, and our call center always has the answers for those. And that's all I have for you today. Thank you.
Thanks, Juan. There was just a request to hear more about mechanical and envelope rebates and integrated design through the New Homes program.
Okay, let me go back to that. So there are 2 pathways. One is if you're following the province's pathway, which is the step code system, if you will, BC step code. Oh well, some nice animation there. So this is one of the pathways, right? So right now in the province, you have to build up to step 3, which includes a few things such as like basically involving an energy assessment. There is some standards in terms of air changes per minute and sufficient envelope insulation. If you go above those to what they consider step 4, we have a $15,000 rebate, and there is a step 5, which is a $2,000 rebate. So that's one pathway. A different pathway here is kind of what I was mentioning before. If you have a dual fuel system where you basically combine a space heating and water heating system under the same home, and install a smart thermostat, you would get a rebate for that part, particularly like separately. And if you engage with a professional that can do integrated design process, there is $1,000 rebates for that. And then for each one of, if you provide us with a building envelope design prior to construction, same thing with the mechanical design, there are different rebates for those. I don't know if that really clarified the question. Mike, was that your question?
I was just wondering if there's kind of more information on those 3 things and how we get that. So just, there used to be a list of people for mechanical design, and I don't see that anymore. And just wondering about the integrated design process. I heard from some energy auditors that it's a really hard thing to get set up. Just haven't been able to find any information about these 3 rebates from Fortis. I've asked a couple of people now.
Okay. Maybe let's take that one away, actually. Like maybe I'll just give you my contact info and we can chat about it, and we can give you further details on that. That might be the best approach.
Sounds good.
Great. Thanks, Juan. All right, folks, so that brings us just a little bit over time, but I really do appreciate Juan, you sharing the information. I know there's a ton of rebate programs out there and incentives for homeowners and contractors alike, and it is difficult to kind of navigate them all. So thanks for taking the time to share with us some of Fortis's rebates. And yeah, thanks to everyone on the call for sticking around and for joining us this morning. Thanks again, James, for imparting your deep well of knowledge, some of it on us. Really appreciate it, and I hope everyone enjoys the rest of their day.
Thanks, everybody. Bye now.